Hello students, this is Anjali Diwalkar. I am going to teach you engineering mechanics. In that, I am going to cover a portion of space force from equilibrium. In the last video, I had told you about the basics of space force. Even I have told you about how to represent a force in a vector form, how to take a moment and all. So we'll solve one problem of a moment. See, a force of 50 kilonewton is acting at a point A to B. Okay, and find the moment of a given force about a point D. See, F force is given to us, and now we are supposed to find out first the force in a vector form: Fxi, Fyj, and Fzk. See, A to B we are going. Okay, so this will become x2 and this will become x1. So 6 minus 2 will be there. Minus 2 minus 3 will be our y2 minus y1, and minus 3 minus 4 will be our z2 minus z1. Okay, if I solve it algebraically, we'll get an equation like this: 6 minus 4 is 6 minus 2 is a 4, minus 2 minus 3 will become minus 5, minus 3 minus 4 will become minus 7k. Likewise, 4 square plus 3 square, 5 square plus 7 square. We don't need to bother about negative sign over here because it is we are squaring it. So if we solve it, we'll get this much fx. This much is fx. Okay, 10.08 is fx. 26.35 is fy, that is negative. Minus 36.899 is fz. Okay. After we find out the vector force in vector form, we are supposed to find out the position vector. R is equal to rxi, ryj, and rzk. To do that, see, we are going taking a moment of a force AB from D. So the x3 means x2 where x1 will be D and x2 will be A. Okay. So x1 minus x3 will be formula. Actually, farther minus nearer one is the formula. Okay. So x1 is again 2 and these points are minus 1. So 2 minus minus 1 will become plus. Okay. Then 3 minus 1 will be our y2 minus y1. Okay. Then 4 minus 2 will be our last z coefficient. Okay. If we solve it, we'll get RDA like 3i plus 2j plus 2k. Okay. Then we'll take a moment by using this matrix form. Okay. Ijk will be common. Rx, Ry, and Rz. So 3, 2, and 2 will be there. Then Fx, Fy, Fz will be there. Value of Fx is 21.08 minus 26.35 will be Fy and minus 36.89 will be Fz. Then we are supposed to find out just simply determinant of this matrix. I will be there, then multiplication of these two minus multiplication of these two. Then minus j will be there and then multiplication of these two and minus multiplication of these two. After that plus k will be there and multiplication of these two minus multiplication of these two will be there. If we solve it, we'll get a minus 21.08 I plus 152.8 j minus 121.2 k. So these are the moments. Let's find a moment of a given force was being asked to us. So we have worked out a moment in a space force. Okay. Then moment of a force about a line. In the last problem, we have learned how to take a moment about a point. Here we are going to learn about a line. Okay, F is a force passing through the points A and B. Okay, on its line of action. Okay, then we want to find a moment of a force about the line series steps. First of all, find out unit force vector. Then find a moment of a force about any point on the line, that is M point. Find unit vector of a line about which we have to find a moment, that is M line. Then perform a dot product of a moment vector and the unit vector of a line. This gives magnitude of a moment about a line. F line is equal to F point into E line. Okay. Finally, to get the moment of a force about line in a vector form, multiply magnitude with the unit vector of the line. M line is equal to M point into E line. Okay. Then we'll solve one problem. A force of 10 kilonewton acts at a point P 2, 3, 2, 3, 5 and has its line of action passing through the Q 10 comma minus 3 minus 4 plus 4. Calculate the moment of this force about an axis passing through the straight through the point where S is a passing through ST, where S is the point 1 comma minus 10 comma 3 and T is 5 comma minus 10 comma 8. Firstly, we'll find out the force. Okay, 10 is given to us 10. PQ means Q minus P means coefficients of Q minus coefficients of P will be there. Accordingly, we'll find out force here. Then we'll go for point moment R into force. To find out R, for R, SP is there. So S for SP, P minus S will be there. By doing that calculation, we'll find out, as just now I have told you how to work out. SP is there, so this point minus this point will be there. We'll find out this position vector. Then we'll take a moment about point. IJK will be there. Then Rx, Ry, Rz value will be there. Fx, Fy, Fz value will be there. Then by doing determinant calculation, we'll find out this value. Okay. Then E line we are supposed to find out. E line is nothing but EST. So S minus T will be there. Okay. So coefficients of S and coefficient of T we are going to use. Okay. So T minus S. Okay. So second point is this and first point is this. So accordingly 5 minus 1. Likewise, we have worked out AEST. So we worked out the line EST. Okay. Then to find out a moment about line, moment about point into position vector about line, we are supposed to work out. Okay. Then if we work out the determinant of it, we'll get a value like this. Okay. So we'll put it into this equation. 86, this was the value. Then 6.625 was the EST, just now we have worked out. We'll put it over here and we'll get the moment about the line. Okay. Then lastly, I'll tell you about the vector components of force. Find F, that is F is equal to Fxi, Fyj and Fzk. Then find unit vector E line. E line is x2 minus x1 of I, y2 minus y1 of j, and z2 minus zk, z2, z1k. Find magnitude of force component. F is equal to F into E line. Okay, Fxi, Fyj and Fzk and whatever we have worked out here. Vector component of force is F into F line. Okay, that's it from my side. Thank you very much.